Today in Capechi's Corner, we're going to look at special parallelograms. Before we take a look at special parallelograms, let's remember the properties that are true for all parallelograms. The first is that opposite sides are parallel. That's by the definition of what a parallelogram is. And then the second one is that opposite sides are congruent. We also know that opposite angles are congruent. And the last one is that diagonals bisect each other. So as we look at these special parallelograms, all of these things are true, along with the new properties we're going to look at. Now, before we get into more detail, we have to remember that parallelograms are quadrilaterals that have opposite sides parallel. When we're looking at parallelograms, we have some special types. The first two, we have rectangles and we have rhombuses. And they're going to have certain properties that go along with them. Now, when we're talking about a square is both a rhombus and a rectangle, so they're going to share the properties of both of these types of special parallelograms. Now, when we're looking at rectangles, we know that the diagonals are congruent. We also know that all angles are right angles. And we know that the diagonals form 4 isosceles triangles and 2 pairs of congruent triangles. So let's take a look what that means. So in looking at this rectangle right here, I know that diagonals bisect each other because that's a property of a parallelogram. I also know that the diagonals are congruent because it's a rectangle. And so what happens is they form 4 isosceles triangle. There's one here, one here, one here, and one here. So the diagonals form 4 isosceles triangles. When we're looking more specifically at each of the triangles, there are 2 pairs of congruent triangles. So I have the markings here. We know that the opposite sides are congruent of a rectangle. So in taking a look at this, we know that this triangle right here is congruent to this triangle. And we know we have a second set of triangles that are congruent. So when we're looking at this example of a rectangle, remember the diagonals are congruent, we just talked about that, and that the angles are right angles. We also remember with the diagonals, besides the fact that they're congruent, because it's a parallelogram, parallelogram has diagonals that bisect each other. So if I first start with that AD is equal to 12, that makes this piece here 6 and this piece here 6. We also know that AD has to equal BC because it's a rectangle. So that's also going to make this piece 6 here and this piece 6 here. So when I'm filling in my blanks here and identifying the other segment measurements, I know that BC is equal to 12, again because the diagonals of a rectangle are congruent. And I broke it up into pieces because, again, diagonals of a parallelogram bisect each other, and a rectangle is a parallelogram. So that makes BE has a measurement of 6, and EC also has a measurement of 6. Now when we're looking at angle measurements, we know the measure of angle EAC is 60. Now remember, we know the rectangle has a 90-degree angle, so we know this makes this angle here 30. Now also with the parallelogram, we know opposite sides are parallel because the definition of what a parallelogram is. So this makes AD a transversal. So angle ADB is going to be 60 degrees also because they're alternate interior angles, and we're going to have 30 here as well. Let's take a look at what we have. We have the measure of angle BDA, which we just found to be 60. And we have the measure of angle BAE, which we just found to be 30. Now the last piece is the measure of angle ACE, which is this angle right here. Now let's think about this. We already looked at diagonals. We said that they were congruent and they bisected each other. So we said that segment AE is 6 and segment CE is also 6. So that makes obviously that those sides are congruent. And what happens is when we take a look at that, this triangle right here, that's where our focus is, I realize I have an isosceles triangle. So that makes this angle right here is 60, and this angle here is also 60 because the fact that the base angles are going to be congruent in an isosceles triangle. So the measure of angle ACE is equal to 60. Our next special parallelogram we're going to look at is a rhombus. Now, we have a few things dealing with diagonals with a rhombus, but before we look at them, remember that with the parallelogram, that the diagonals bisect each other. Now, specifically for a rhombus, we know that diagonals are perpendicular, so they will form a 90-degree angle in the center where they meet. We also know that the diagonals will bisect 2 angles. In addition to that, we know that all sides are congruent in a rhombus. Now let's use those properties in identifying different angles and segments of this rhombus. So we have given that measure of angle BAE is 50 degrees, and the side there, segment AC, is 4. So let's see what we can label from there. Now we know that the diagonals meet at a 90-degree angle, so that means all four of these angles in the center are 90. We also know that the diagonal bisect angles. So if this is 50 here, we know that this side is 50 as well. Now because we have parallelogram, again opposite sides are parallel, so we have same side interior angles are going to be supplementary, so that we know this angle right here is supplementary to this angle right there. So if we have a measure of angle A is 100, we know that the measure of angle C has to be 80. And because the diagonals bisect the angles, that makes each of those pieces there 40. So the measurement of angle ACE is equal to 40, and the measurement of angle DCE is also equal to 40. So let's take a look at our angles that we have here. We have the measure of angle AEB, which we have identified as 90 because we know that the diagonals of a rhombus are perpendicular. We know that the measure of angle CAE is equal to 50. We have identified that. The measurement of angle ACD, that big angle, has a measurement of 80. And then we're also asking what the measurement of angle ABE is, which we haven't identified this. That's the angle we're looking for right there. Now again, because opposite sides are parallel, we again have a transversal of BC. So if this angle here is 40, these are alternate interior angles, so this piece right here is also 40. So that's the measurement of angle ABE. Now looking at the sides, we know that AC is equal to 4, and because a rhombus has 4 congruent sides, I know that CD has a measurement of 4. Now when we're looking at a square, which is also a special parallelogram, we discussed earlier the fact that a square is a rectangle as well as a rhombus, so it's going to share all of those properties. So it has all sides are congruent, similar to a rhombus. All angles are congruent, which are similar to a rectangle, and that means all angles will be 90 degrees. Now when looking at the diagonals, we know that they're congruent because rectangles have congruent diagonals, and because it's also a rhombus, it will bisect two angles, it will be perpendicular. In addition to that, remember in dealing with all parallelograms, the diagonals will bisect each other as well. Now looking at this example of a square, we know that AC has a measurement of 12. And we know that diagonals bisect each other and they're congruent, so that makes the segment AE is equal to 6. And segment EC is also equal to 6. We also know the measurement of DB is going to be 12 as well since they're congruent. So let's fill in what we have. EB, we said, is also going to be 6. And ED is going to be 6 as well since the measurement of BD is 12. Now looking at angle measurements, we know a few things. We know that each angle has to be 90 degrees. We also know that the diagonals bisect each other, so when we split those in half, we're going to have measurements of 45. We also know that we have a 90 degree in the center because they're perpendicular. So in looking at the measure of angle BEC, that's going to be 90 since diagonals are perpendicular. We also look at measure of angle EBC, which we just said will have a measurement of 45. We have a few more theorems dealing with these special parallelograms. The first one here says if an angle of a parallelogram is a right angle, then the parallelogram is a rectangle. And this is why. So we have one angle already marked as 90. We know that we have opposite sides that are parallel. So we know that same side interior angles are going to be supplementary. So if this angle is 90, that makes this 90, since this would be my transversal here. Now remember, we have another set of parallel lines as well. So if I make this my transversal here, and I make this other set parallel, we also have same side interior angle here, so that's 90. We can kind of keep going. We know opposite angles of a parallelogram are congruent. So if I'm just given that one angle of the parallelogram is right, there's a few different ways we can get to prove that the other three angles are 90 degrees as well, and then we can conclude that the parallelogram is a rectangle. Our next theorem states that if two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Now again, remember in a parallelogram, opposite sides are congruent. So if I know that this piece right here is 6, I know that that opposite side is 6 as well. I can do the same thing with the other pair of sides. If I know this is 6, again I know the opposite side is 6, so therefore I can conclude that all four sides are congruent, therefore it's a rhombus. In our last theorem for today, it says the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. So let's think about what that means. Right here I have marked that D is my midpoint. I said this is segments are congruent. So that makes that piece 4. And so D is equidistant from that vertice. Same thing with this other vertice over here to B. It will also be 4 as well. And that makes DC also 4. Now we can fill in what we have so far. So we know DB has a measurement of 4. And we also know that AB has a measurement of 8. And DC has a measurement of 4. Now when we're looking at the big triangle, we know it's a right angle. So I know the measure of angle C is 90. And I know the measure of angle B is 42. Now this piece right here and this piece are congruent. So that makes an isosceles triangle. So that gives me 42 degrees right there. I know this other piece right here, again, we have 90, so that's going to be 48. Now, in getting the measurement of angle A, I can get that it's going to be 48 one of two ways. Again, I have an isosceles triangle, so this angle and this angle will be the same. I also know the big triangle has to have a sum of 180, so I can take the measurements I have so far to figure out that the measure of angle A is 48. Now, in trying to figure out what this angle is right there, again, there's a small triangle here, which I know has to have a sum of the angles have to be 180. So that makes this piece right here 96. And I have a straight angle right here, which gives me 84. So now in just labeling up the diagram, I pretty much have found all my measurements of my angles. So I just have to fill in what I have. The measure of angle A is 48. The measure of angle DCB is 42. The measure of angle CDB is 96. And the measure of angle ACD is 48. My last measurement says measurement of angle ADC, which has a measurement of 84.